We'll talk about 3 case studies here. Application of crowd counting to 3 different scenarios. Fairly interesting use cases. And we'll finally look at one bonus application, something which we may not have thought of. The first one is saving penguins. The entire ecosystem of Antarctica is at risk. Global warming is a major challenge. Human interventions. There are several factors which are impacting, and penguins, which are at the top of the food chain, are naturally impacted. Scientists have been studying penguins for hundreds of years, but they don't have enough data to prove the decline in the population. It's a classic case of a business which has a lot of hunches about what is happening out there in the world, but don't have any data to prove it. So, starting with this, the Oxford University set up a citizen science initiative called Penguin Watch about 10 years back. The aim was to set up camera traps in multiple locations in Antarctica. 16 locations, and about 100 cameras were set up. And they started recording time-lapse pictures. Every hour, a picture is taken in each of these cameras. And over the years, these pictures, this database started building up. So today we have millions of pictures, a very rich database, which we can start using. But the challenge is, you have all of these as unstructured data. How do you get the count out of that? If we have to get into deep learning models, we need good training data. We have to painstakingly identify the penguins and train the model what a penguin looks like in different scenarios. That's where a crowdsourcing initiative was launched on the Penguin Watch website, where volunteers from around the world were asked to come and contribute time to label the pictures. This is how it works. You get into the website, and once you click and get into the tutorial, it says you just have to simply place markers on the penguins. Places where you can't identify the penguins, just leave it blank. If you can see that the picture is blurred and not penguins in sight, ignore them as well. And also identify any other birds. So you have birds, humans, and other animals coming into the picture, just identify them. So you have one marking for adult penguins, one for chicks, and for other eggs and other animals. So with this, a person goes through the process, labels it, and once they are done, they just click Save Submit. And this is pretty helpful in building a training data. This is the toughest problem facing deep learning. And with this initiative, today, tens of thousands of images have been labeled. So we worked with Microsoft, and there's a team called AI for Earth. So they do spectacular work in applying AI to solve environmental problems. Counting penguins, monitoring salmon in rivers in Washington, spotting elephants from drone imagery. So a variety of interventions are being taken up, and all of these are cases where AI is being applied. So we worked with them to solve this problem. Starting off with all of these images, we tried to find out the right approach to count the penguins. Coming to think of it, this is very similar to the crowd counting problem, where you have challenges with crowds of people. Same challenges of camera angles, occlusion, perspective distortion, density difference. With the weather changes, brings in different lighting. So all of these exist here as well. So we took up the data, and about 30,000 images. Initially, we had to exclude those where there was no annotation. And then with the rest of the images, we went about building the model. Here's the approach we took. For each image, we split it into 3x3 patches. So there are 9 such smaller images we end up with. Each of these images is passed through this deep neural network. The architecture we use here is a cascaded convolutional neural network. So there are 2 layers here. The first layer is called a high-level prior, where for each of these images, it does a ballpark approximation. Are there likely to be 10 penguins, 20, 30? Initial crude approximation is done. So this is more like a classification approach, where you pass this through the model, which classifies it into one of 5 or 10 buckets, 0 to 50, 50 to 100, 100 to 150. It just does this initial approximation and slots it into one of these. And then there's a second stage which does the density estimation. And while it does the initial density estimation, it takes inputs from this higher level prior stage as well and combines both of this information together. So now we get refined density estimates. So the density maps you see here, the heat maps in blue, are those images generated by the model. So when you pass the image, splitting to 9 and then converting it into density map, this is then aggregated together as a count, and then you get overall count for the entire picture. So this way you're handling a variety of challenges. When you split it into different portions, some aspects of density differences are being handled. You're able to handle these locally. And in terms of the perspective distortion challenge also can be handled. So this is the way where we are able to come up with the right estimate of number of penguins in a picture. In terms of the model, other details, we ran this on an NC6 machine, which took up training for about 3 to 4 days. And the mean absolute error was landing in the range of about 10. So we used two error metrics, mean absolute error and mean square error. There was a paper published by Oxford University on this, and we compared the results with that. And when we saw this was close, we decided to bundle this out as an API. We Dockerized it into an API, and this has been hosted on Microsoft AI for Earth API page. So this initiative and several other initiatives, what has been done is, as an outcome of all of these efforts, a public API is created, which AI for Earth hosts. And it makes it available for organizations where they can come in and just plug into this API, pass their pictures, and are able to score it for either detection, classification, or counting use cases. So this is a walkthrough of IPython notebook, which connects to this API. And what it does is it pulls the images from Azure Blob storage. So as we do a walkthrough of this, we initially initialize the libraries, and then we do the authentication of the blob storage. And then IPython notebook pulls in the images first from blob storage, and then we pass each of these images to the model to do this counting. So now you see here that this function talks about getting the images, count, and plotting penguins. And so those are the three functions which makes the API calls. So having run this, let's go on to the retrieve, display, and plot the images. So firstly, we are showing all the images that we have retrieved from blob storage. And then we will start scoring each of these and passing it to the model. So you can see that these are the images which we have pulled first. And now we'll go on and pass each of these images to the model. And the model will return us a density map and the count. So that's running currently. You can see that the ground truth is 10, and the model has estimated 10, and you can see the density map. So this way we can cycle through low density, high density populations, and we saw that the model was able to do a fairly good job. Like I mentioned, the mean absolute error was around 8 to 10. So this is an ongoing initiative where we have these models being used by the researchers to start finding out and answering questions like, when do penguins move? What is the migration pattern? And how does the population change at different times of the year? Month by month, what are the changes? What are the predators that come in there? How are the eggs impacted? A lot of such questions earlier, which people had to be there and painstakingly observe, are being solved by this modeling approach.